Hi everyone, my name is Yuri Gubanov, and my today's presentation is devoted to our new product, Belkasoft new product called Belkasoft Incident Investigations, or for short, Belkasoft N. Before I begin and to wait for some late attendees, I'll give you a very brief information about what Belkasoft is, and then we'll go directly to the topic. So the company I'm working for is totally devoted to digital forensics and incident response. We don't do anything else, no system software, no games, no consumer tools. We started at 2007 and now we have offices in 3 countries, including office in California, the United States. Most of our customers are working in law enforcement organizations. We also have a number of corporate customers. In total, we have more than 130 countries all over the world, all continents except Antarctica for some reason. On this slide, you can see some of our US customers. We are proud to have the FBI, Secret Service, DHS as our customers in the United States. We also have some sound names in corporate world, such as Apple, Sony, Disney, all the big 4 companies, and others. Outside the US, we have multiple police departments in countries in Europe, Australia, Latin America, Asia, Africa, and others. We're also pretty proud of our recognition last few years. If you know what Forensic Forecast Award is, we were nominated 3 times out of the latest 4 years as a commercial tool of the year. We were in the finals. There are just 3 nominees which go to the final step of this award. We were there along with Celebrite and Magnet Forensics as a commercial tool of the year, including this year 2021. And this year we also were one of finalists with the same companies, by the way, as a DFIR Team of the Year. So we are pretty proud of some recent recognition Belkasoft got in a well-known competition. So what is Belkasoft Incident Investigations, our new tool, which we also abbreviate as Belkasoft N? So the goal of this tool is to help investigating hacking attempts of Windows-based computers. So everything around hacking, malware could be investigated with this new product. And our users are incident responders, those who solve digital incidents. Unlike all our previous tools, which are mostly aimed to law enforcement and government organizations, this particular tool is mostly useful for businesses, while of course our law enforcement customers can also use it, but slightly different than those who are using our main tools like Belkasoft Evidence Center X. So what Belkasoft can do, it can find various traces which are typical for tricks used by hackers to penetrate the digital infrastructure. It looks through different sources, such as registries, event logs, some specific files which are less known, and it tries to gather as many traces, as many evidence which is possible, and feed it into one screen so you can get an easy overview of what was going on in your system. So let's download it. To do so, let me send the link to the chat. You can go to belkasoft.com/trial. On this link, you'll find all the Belkasoft products which we have so far, and particularly you'll find Belkasoft N. So please download it and give it a try on your favorite sample data. or your own computer, and you will see how it works for you yourself. Okay, let me start with something called cyber kill chain, and I'll show how Belkasoft N can help you with the different steps of these models. This is a model by a well-known company, US company called Lockheed Martin, and it tries to define steps used by cyber attacks, by cyber attackers during cyber attacks. And it helps you to understand on each step what you can analyze, what you can protect from to stop attackers in an effective way. There is a link, a little bit too long to type in, but I believe you can just Google cyber kill chain by Lockheed Martin, or just search on lockheedmartin.com. So there are 7 steps, starting with reconnaissance and ending with actions of objectives, how the attackers try to get most of your infrastructure. Belkasoft cannot help with the first step, definitely. I don't think there is any software to help with the first step, but we can help you with all other steps. So starting with weaponization, which is the second step in this model, you can see things like list of files which were downloaded or sent by emails. You can also, if there is something about a known attack, you'll probably have a list of hashes. The new product doesn't work with hashes, with search of hashes here. You can use our main product called Belkasoft X. In its corporate edition, it has many features which the new product has as well. So by the way, Belkasoft N is much less expensive than our main product. So there are some options. If you work with incident response, you can opt just for Belkasoft N, which is like 3 times less expensive than our main product, Belkasoft Evidence Center X. But if you also need some forensic features, you can opt for the corporate edition of Belkasoft Evidence Center X. And though it's much more expensive, but it gives you much broader set of features, including those for incident investigations. So the next step is delivery, how the payload is delivered to the victim. Could be via email, remote desktop connection, or maybe connected USB devices. Exploitation. You can find different traces, like using browsers, opening some files, creation files during the exploitation of during this phase of attack. The installation, how the malware, how the malicious code persists in the system. There are multiple tricks, more common and less common. Say the malware can write itself to the startup. There is a recognizable if you know where this information is stored. Scheduled tasks and services are also pretty common, but there are some less known ways to persist in the system, such as Windows management instrumentation, the abuse of event subscription. And I will show you today how it works in real life. Command and control. This phase this step can leave some traces in memory, such as page file or hibernation file. If the payload is downloaded at every startup, it will leave some traces in registry file and probably event log. Finally, Things like remote desktop connections, file manipulation traces can be found on the last stage of this model of the cyber kill chain. You can also review the timeline, which will show you all the events in the system found by Belkasoft, and you will also be able to find some less known stuff which will not be shown on the main window of the software. It's probably better to show in the product, so I will show you this in a couple of minutes. So that was a cyber kill chain, and in the tool we are using slightly smaller model. We group data based on the traces of persistence of malware, traces of execution. We also show you system event logs, but you know that system event logs may contain, and indeed they contain lots and lots of data. So instead of showing you the entire log, which you can do with any third-party tool, we'll show you just a fraction which is specific to particular types of attacks and tricks used by hackers. So we'll show you just most useful events. And finally, there are a number of nodes in the product which shows you smoking gun, meaning something what really helps you to understand, quickly understands that something wrong was happening in the system. So what kind of artifacts we process and extract? Here you can see some of them, not all the artifacts, but most important. They are based on registries, on non-standard registry files, less known than a typical anti-user, for example, and non-registry files, such as system event logs, pre-patch, traces left by TeamViewer, WMI event subscription, and so on. And at the top, you can see what we extract from the registry, what we extract from registry files, which are non-standard things like syscache, mcache, shimcache, and so on. Let me go through some of those artifacts and break them by persistence, execution, and other stuff. So things like app init DLLs. In the parentheses, you can see the number, which is a number in the site called mitrid.org. So if you go to this site, you will see those numbers here, like T1546, and you will get the description of particular type of attack. You'll see the number, you'll see some details, how you can understand something about this attack, some mitigations, references, and so on. So this number T1103 is taken from the mitri.org. So this app init DLLs, if someone abuses the list of the DLLs that are loaded by user32 DLL at the load of every process, this can be used to obtain privileges, say administrative privileges. And this is one of the tricks used by the malware to escalate privileges. Okay. Logon scripts could be a batch file or Visual Basic script or the JScript, which is executed during a login to Windows account. Again, arbitrary code can be executed. The startup already mentioned something what is executed during every Windows startup. It's possible to change an association of default applications. So if you bind an arbitrary program to open some type of a file, say it, instead of Microsoft Word, you can bind something else to open a docx file. And this this arbitrary program can do something bad and then launch Microsoft Word, for example. So everything will work like you expect. You click on Word file and Word is open, but in between something bad is executed. Services is probably one of the favorite tricks for persistence. If malware installs itself as a service, it will be automatically loaded by Windows at every startup. And what helps here is filtering services by date of installation. If you see some pretty new services, those are of interest. Schedule tasks. You know that Windows allows you to schedule tasks by like every day or every every hour, and there could be a complex schedule. And you know that a task can be scheduled even remotely if your system allows that. Okay, next portion of artifacts is execution. There are things like BAM, Background Activity Moderator, and DAM, Desktop Activity Moderator. They are slightly less known services, and they control activities of applications. First is devoted to background application, and the second is desktop applications. They are less known because they are recently introduced in Windows 10 after the version 1709, and particularly they store full path of the executable file that was run on the system. So using those two services, you can understand that this or that executable was ever run, and you also have a last execution date and time. Interesting and less known proof of execution is WMI event subscription. You have probably heard about fileless malware, the malware which is never stored on the computer. Using things like WMI event subscription, every time when the computer loads, it downloads itself from some remote server, goes through the same routine every time, and then particularly it deletes the downloaded file. So it only persists in memory, what makes it less less noticeable to a responder. And there is a PDF, a link to the PDF about this technique, which you can read for more details. Some other non-standard registry files which can store execution traces are amcache and syscache. Amcache stores data about applications which are executed. Again, I'm giving you a link to get more information about that. Also, the shim cache is described in the link. And there is also something called syscache with no clear purpose, but which also stores data about app execution, something about software restriction policies, and application locker. Remote connections, of course, help you a lot to understand where your data came to, where the command and control center is possibly. And here, old good registry antiuser.dat helps you to understand what remote computers connected to the victim, and vice versa, what remote computers were connected from the victim, possibly to send some documents and some data which are interesting to attackers. Let me show what it looks like in the product. On the screen, you can see incident investigation. Those of you who work with Belkasoft X, you know this picture. It looks pretty similar to Belkasoft X. Here you start with the main screen, which allows you to create a case and open the case. I already processed a case, so I have some data already extracted. So let's open the main tab called Incident Investigations. And here you can see artifacts grouped by persistence, execution, system event logs, and recent files. And also there are downloaded files. So those are smoking gun. I'll go through them later. The case I'm working with is pretty interesting. It was a virtual machine which was deliberately infected with something called Coadic, and it was K0 edic, so it was 0 instead of O. And particularly, attackers use WMI event subscription to obtain persistence on the target host. Many exploitation frameworks, by the way, like PowerShell Empire or this Coadic, allow to achieve this persistence automatically by using WMI event subscriptions. So it becomes more and more common, this kind of trick. So we have this detection in Belkasoft N, which is kind of unique feature. I haven't seen it in third-party and competitors' software. And particularly, there are two items here. Let's select the first one. And what you can see here, some arguments like that. Let me zoom it in. So you can see that this was a script running from the command line, and we can see that it was HTML application. So at the computer startup, mshta.exe will run with this argument every time doing something. So let me bookmark this item just in case. And now let me try to find this file and understand what it is about. Here in Belkasoft N, we also have the file system like in our main product. So going to the program data, finding this trg something something.hta, I can open it in hex viewer, large window. So I can see that's actually a text file, not a binary file. So instead of reading those texts in hex viewer, let me just select everything, go to the Notepad++, and I think I copied it as a hex and I need it as a text. Okay, so something really interesting is happening here. So we can understand that it is something really not innocent. What catches my eye here is the IP address, right? So you can remember this number ends with 77. And also you can see that looks like this HTA downloads something from this host, and it called fqbaw.wsf. It stores it under temporary folder. It starts it afterwards, and then it deletes the file, right? So that's how it works. And this file, you will not find it on a hard drive. So pretty interesting. Okay, so what we can do next? Let's go back to the product, and we can search for this FQBAW. Actually, I have already done that, preparing to the presentation, and I can see 65 hits. So this downloading, starting of this file in a temporary folder. You will also find other stuff like creating a service using this file and so on. Most of those artifacts are stored in system event log, and one of them is stored in registry. Okay, so again, to repeat, the malware in our case will persist in memory. No traces will be found on the hard drive unless you are trying to recover this FQB something, because you saw it was deleted with a simple delete command. Okay. So by the moment we know that we have a server ended with 77, which loads some bad stuff into our network, and it does it through WMI event subscription. So what else do we have? Let's return to the incident investigations and go to system log 7045. 7045 stands for an installation of a new service. So let's look what services were installed. Let's sort by time of the installation, and remember that newer services are most something what you should pay attention for. So most of the services would be installed, would have been installed at the system installation, and then as you install some software, those pieces of software can also install newer services. But after an attack, you'll find some very fresh installed services. So in our case, the most recently installed service was a services with a weird name, which already looks suspicious. It's ARB something, right? And see the date. It was 26th of October 2019. And again, if you inspect the path, it was at bitsadmin installing this FQBAW, right? Okay, so services, to repeat, is one of favorite tricks used by malware to persist in the system, and if attackers can install a service, they automatically get admin privileges once a service is started. Let's go to scheduled tasks. Again, this is another pretty popular way to persist in the system. So actually, there are much more scheduled tasks than you saw on my screen. However, you can do the filter by the task name. In this way, we will see just one scheduled task, and again, you will see that it does something bad. Again, that's mshta, and it runs another file, bss something hta. Again, going back to the file system, you can inspect it, and it looks pretty much like the other one. Okay. What else attackers can do once they got a compromised account? They definitely do not want their account through which they penetrated the system to be blocked. The solution they might have used is to create a new account. Again, let's go to the file system and expand users. So there are a number of users, and I have already sorted those folders by created UTC time, and I can see some user call support. And remember the time of the service installation, it was 26th of October, and that's exactly the same day. So we can guess that this user was created by attackers. Okay, so let's return back to the incident investigations and go to the recent tab. Here we have documents, link files, and OpenSafe PIDL, which is kind of also kind of most recently opened files. So if we go to the documents, we can see that a number of documents were opened by this new user called support. So you can see some receipt 1699 34 doc, and possibly these are weaponized documents having some scripts inside, some macros probably. Okay. Again, what you can do here, you can sort by last write time and review all the documents recently opened. So those ones look innocent. This one looks kind of strange. There's some document with a Russian name, which translated as transactions, and then you can see received something, transaction.txt, and then sysmonitor was downloaded, and then this HTA. So here you know that something bad happened. So that's my first guess. Maybe this was a regional attack vector. So probably this file was the bad file opened by mistake by a user of the system called Taylor. Right? Okay, you can also go through link files to open PIDL files to see some corroborate evidence. And let me also go to the remote services, which are stored under system event logs node. So particularly, what I can see here is our all good 77 host to which the remote connection was open. So again, probably the malware was, so we know that the malware was downloaded from this host, and we may guess that something was also passed from the victim host to this 77 malicious host. What else can I do here? I can go to the timeline. The timeline, let me clear the filter. The timeline contains all the events in the system, like computer was started, log event written, DHCP address obtained, and so on and so forth. So in my case, it was 36,000 of events. Of course, it's hard to understand everything. It's too much. So what I can do, I can filter by different criteria. Most interesting filters are event type and time. So I can filter something around the incident and also to see things happening around the downloading or say it file execution, or I don't know, password change. You can also find some interesting events like login failed. Login failed may mean that malicious code was trying to brute force some users of this computer, and we can see some evidence of that. And remember the date 26th of October, we can see that administrator was trying to log in and failed, but we can also surprisingly we see something in August, 2 months prior the hack, right? Okay, let's create another filter, and now download start and finished. Again, it's already filtered by sorted by time. So Thunderbird, probably something good, some installer of LibreOffice, Chrome, blah blah blah, and now you can see something called application-form.exe. This looks really really suspicious. You know that you may receive an email that you can get back like $1,000 because you are lucky, or because you use some flight ticket or whatever. And people who are less used to the internet and to a scam like this, they could download these kind of forms, trying to fill in and so on. So surprisingly, we see that the first attempt to hack into this computer was on August 18th, right? So for some reason, maybe this computer has been switched off, or maybe attackers were not interested in it. The real hack happened 2 months after. So you can see some Russian named files here, and then you saw some recently opened files which were not downloaded but which were opened through other way. And by the way, downloaded files are conveniently gathered in the main tab, so you don't have to do filters in the timeline. Okay, so that's briefly what it looks like. Of course, there are standard things like search, like creating a report with a right click, like bookmarking, and so on and so forth. All the windows are accessible through this button at the left. You can see things like plist viewer, registry viewer, and SQLite viewer if you need to open a particular format from your case. And I have shown you the other ones. So let's go back to the presentation. And some conclusions. So Belkasoft N, Belkasoft Incident Investigations, or for short Belkasoft N, is Belkasoft's new DFIR tool developed specifically for digital investigations of various incidents, typically for corporate use, but we also have some interested law enforcement customers. It helps incident responders to quickly discover attempts of installing a malware or hack your network by gathering most common traces into a single screen. Belkasoft N shows traces of malicious code broken by persistence, execution, system event logs, including remote connection, as well as different smoking guns like downloaded files, recently opened files, remote connections mentioned already, to help understand initial attack vectors. You can get more info on the product going to belkasoft.com/n, and the trial is free to test. Available at belkasoft.com/trial. Let me quickly remind you about other Belkasoft products we have so far. Belkasoft X is our main product for digital forensics and incident response. It's more expensive, and in corporate edition of this tool, you will also have those incident response features. You may also consider it if you need both forensic and IR features. Belkasoft T is a triage tool which you can use along with Belkasoft X. It's a portable and quick tool to scan running Windows computers to understand if anything interesting is stored when you are in rush or when there are too many computers to analyze entirely. We also have Belkasoft R, which is a forensically sound remote acquisition of different types of digital devices, including mobile phones, smartphones. And also there is a free tool called Belkasoft Live RAM Capture. It's the smallest utility in the world, which will help you to capture live memory of a running Windows computer. Completely free, less than 100 kilobytes. The output is standard, so you can analyze it with Belkasoft and any third-party memory analysis tool. So that's what we have for the moment. If you are interested to get more information on our tools, you can go to our website, go to resources. We have white papers and we have articles. So test Belkasoft N and other products by Belkasoft yourself by using belkasoft.com/trial. If you are an academic working in a university or a college, we give you up to 95% of our tools to help your students work with leading forensic tools for very, very small fraction of the cost. Any help needed, we have a support at belkasoft.com for technical questions and sales at belkasoft.com for sales-related questions. And remember, Belkasoft is proud of our affordable pricing, much less expensive than competition, which can be like 2, 3, 4 times more expensive than our tools, especially for Belkasoft N, which price is set to a very low affordable number. So that's it for today. If you have any questions, please type them into the chat window and I'll be happy to reply. Let me go through what we have so far. I don't have any questions so far, so let me wait for a minute probably to see if you have any questions.